Hello, everybody. How are you all doing? Great. So, welcome everybody to my talk about effective pragmatism. I'm continuing the great puns started by Max. Um, yeah, today I'm not going to talk about how effect works or how you're supposed to use it in your production systems. I would like to take a step back and talk about why we should consider using effect in the first place. What value does it bring to the businesses, and what is software quality? Why does it matter? How does effect come in to the topic of software quality? How does it allow us to achieve good quality software? And last but not least, talk about the adoption of this amazing technology and how we can achieve a wider scale adoption in the ecosystem. But before we get into the meat of it, let me tell you first a few words about myself. My name is Attila Večerek, and I'm currently a senior staff software engineer at Zendesk. Zendesk is a fairly large-scale company in the customer experience industry. I'm based in Copenhagen. I love everything about cooking, cycling, and board games. But professionally, I'm a software engineer and I love my craft, and I have about 10-ish years of developer experience, out of which the last 7.5 years I spent at Zendesk. Now, spending so much time at a single company has its pros and cons, but it also gives you a very interesting perspective. For example, I have witnessed the long-term consequences of the code I write and deploy to production. Its consequences on the long-term maintainability, scalability, and performance of our systems. And the mistakes I made and the mistakes my colleagues made, they all contributed to who I am today. And I have learned valuable lessons in those mistakes. And hopefully today I will impart a bit of those lessons to you. So let's get started. First of all, what does a business want? We don't have to romanticize businesses. Their major and foremost mission in this world is to generate profit if they want to provide value to the rest of the world. And, in an idyllic world, what they all would like to achieve is to, and I'm specifically talking about software companies, what they want to do is provide high quality software, hopefully or ideally immediately, and something that doesn't cost them too much money so that they can have large profits. But the fact is that these companies have to deal with all sorts of constraints throughout their operation. Constraints like timelines. Sometimes you have to really ship before a very important event, because if you don't, then it's terrible for the business. And then, there's the scope. Businesses have to be very pragmatic about what they ship, when do they ship it, but also they have limited resources. They don't have all the software engineers that they want or need in this world, so they have to consider that as well. And also sometimes regulations and compliance is also in effect. You can think of things like SOC 2 compliance, FedRAMP, HIPAA, and things like this. So what happens in the end, every single company has to arrive at a specific set and mix of trade-offs. So every company will arrive at a unique mix of good, fast, and cheap. Let's talk about the good part of the Venn diagram, and the good part represents the software quality. It represents, and it consists of many different software quality traits like reliability, observability, maintainability, and so on and so forth. And obviously, building software, great quality software, is really hard, and everybody would like to achieve all of these quality traits, but we rarely talk about the cost. They don't come for free, so let me talk about that a little bit. One of the costs is complexity. If you want to build software that is easy to use, it's inevitable that most of the complexity has to be incurred on your end of the system, in the systems that we build. And this poses quite a few challenges. I'll specifically mention two. One is over-engineering, and the other one is the exact opposite, oversimplification. Both are challenges and both are risks that we have to deal with. People generally understand that, yes, to build high-quality software, some complexity needs to be implemented, but then, they have all the good intentions and they build these crazy systems that deal with, millions of requests per hour and stuff like that. But then somewhere along the way, they make mistakes and suddenly you have a big ball of mess. And then people who have been burned by this complexity in the past, they might land on the other side of the horse and say like, hey, this is not how we should build software. It must be much simpler, otherwise we will drown. And then in this pursuit of simplicity, they might overlook, robustness or correctness, and that also is a risk. Then we have human resource costs. Obviously, building these large-scale, great systems requires great engineers who cost more money. But then there's also infrastructure cost. If you want to have high availability systems, it comes with redundancy. And redundancy, by definition, means non-cost efficiency. So yeah, you have to pay more. And then last but not least is the opportunity cost, because every single minute you spend on improving existing systems and existing features is a minute that you could be spending on writing new stuff. Also, there are different things that influence the end quality of a software. And these are all choices that we make on a day-to-day basis. We have to choose the right architecture, the right design patterns, and the different sort of technologies like libraries, frameworks, languages, and so on. But what we have to be cognizant of is that we do all of these choices in a given context for the specific job and for the specific people. Now, we could make all the right choices, but if the people cannot apply those things or implement those things properly, then, or even in time, right? You might end up in a situation where you cannot ship on time, or your business will actually run out of funding, and yeah, the dream is over. But at the same time, you cannot justify poor technology choices just by saying, it doesn't matter. We have the greatest engineers in the world. Whatever technology you throw at them, they will take it and they will produce an amazing software. Yes, very often we can do anything with any technology, but at what cost? And this is especially a risk for those most ambitious employees, those most productive engineers. If they feel like they're in an environment where they're constrained and they cannot produce value at their own speed or at their own quality standards, then they might leave your company, right? So technology choices and all these other choices do matter. But the importance is to be able to balance these choices. So we have to stay pragmatic. We have to think of these quality traits on a spectrum, not in absolute. So always target good enough level of reliability, good enough level of maintainability. Don't try to build the most reliable and most maintainable system every single time. There's constant trade-offs, so we have to figure out how to maximize the value in any given moment, while at the same time minimizing the costs. And I will close this section out with saying that architecture and implementation are both equally important. None is more important than the other. Think of the architecture as your strategy. It gives your company and your engineers a direction. It makes sure that you build the right thing. Whereas the implementation, it's more of the tactics. It makes sure that you build the thing well. And yes, it's hard. These trade-offs are very, very difficult. And they live in a context. And the context is the needs of the business. Now, different businesses are at different stages of their life, and they evolve, hopefully evolve, because if they don't, they might die, right? And up here, what you see, this gradient, this doesn't really mean gradient of increasing difficulty. No, it's actually the gradient of increasing complexity. So as your company evolves and starts functioning at a larger and larger scale, it faces different challenges, and there are more complex challenges and very different challenges. But the difficulty is the same. It's extremely hard to lead a startup, and it's extremely hard to lead an enterprise, nonetheless. So let's take a look at each stage a little bit. And this is very academic. In reality, it's like more of a mix and match. So yeah. Let's start with the startup. Its main goal is to validate its product market fit. Find the first customers and be able to build many different features very fast so they can figure out what works. A scale-up figure this thing out, so now they have to accelerate their growth. They need to hire lots of engineers so that they can build more features faster. Whereas a corporate, they need to optimize. They're already at a quite large scale. They have many customers. They need to figure out how to make profit, which means cost efficiency. Then the enterprise is ready to scale even further. But instead of hiring individual engineers, they can actually acquire new companies. And figuring out how to integrate these companies into your main business, that's a huge challenge. And then last but not least, you have the mega corporations. These have to figure out how to diversify. Their goal is to create and expand their revenue stream by targeting and landing in new verticals. And as we go through all these different stages, you can see that these companies have very different goals and very different needs. And the technology choices and architecture choice that we choose at different stage is very different from another stage. Wouldn't it be great to have a technology that can scale with the growing needs and changing needs of your company? Well, that's why we're here. It's a fact, but it's not the only answer. It's a very good answer, but there are other answers as well. You just need to be pragmatic and have an open mind to see all these different options. Now, I want to first start by talking about reliability and why reliability is important for the different sizes of companies. So we have the startups. Obviously, they need to work fast so that they can figure out the product market fit. But they can't land a first customer if their system is always down. It's unusable. So as soon as they gain a customer, they might even leave. So you need some level of reliability to gain that initial trust. Then when you're a scale-up, you need to grow fast. And you need to find the right balance, because if your systems are not that reliable, you can't grow fast enough. Whereas if you focus too much on reliability and not other feature works, then you won't gain new customers faster. So everything is a balance here. Then you have the corporate, and here it's all about retention. Acquiring new customers is always much more costly than retaining existing ones. So that's why corporates need to think about this. And then later stages, they use reliability as a mechanism to mitigate legal and financial risks. Companies at this scale, they have very strict SLAs, which come with financial penalties if you don't meet them. Reliability has many different facets. You can think of reliability in terms of error management or configuration management, the CI/CD pipelines, and many others. Today, I'll be talking about error management only. And the way I see error management, it consists of two parts: error discovery and error handling. Now, Sebastian will talk about error management more, so I will just skim through most of the things here, and he'll delve into the details. So how do we discover errors in our conventional approaches? First of all, by reading. We take the function body, we look at what other functions it may call, go check those, and well, We do it for a long time until we're either satisfied or we get tired. Another approach is what I call the trial. In a trial, we test different things, and by testing I mean unit testing, integration testing, chaos testing. The main point is that you change the inputs, change and simulate the different environments, like the state of your data in the database, or try to induce network errors and see what fails. But then you can also ask a colleague or maybe an LLM. The problem with all of these three approaches is that they aren't particularly fast or exhaustive or precise, and we need something better. And there is a better way, the effect way. Let these errors be discovered by the compiler. You can do it because the errors are encoded in the type system. Now, error handling. Let's say we have this try-catch block. Everybody is very familiar with this. It's quite readable, very elegant, but the problem is it doesn't give you any way to discover what the error is. Then you have the Go-style approach, where you get much more reliability because you know what errors you're dealing with, and in some cases it even forces you to handle them. But as you can see, I couldn't even fit the entire example in this slide, so readability is a concern. We need something that combines all of these things. We want the guarantees of the Go-style approach, the elegance of try-catch, and on top of that, we want first-class in type inference. We don't want to spend our time and productivity on typing the return types of the different functions. We want the system to know about it. And that's where we are. We have, with effect, we get a perfect readability, and the types, we don't really have to write them. They get inferred. For example, in this case, we can see that the create article function returns an effect that can fail with 5 different errors. Then the type system, it can tell us what errors to handle as we write the error handling logic. And the error handling logic is in a pipeline, separate visually, both visually and logically from the happy path. And once we handle all of these errors, you can see that the type system knows how to eliminate the error cases from the end type. But it doesn't necessarily forces you to handle all of the errors. It's all up to you how many errors you want to handle. But you could enforce exhaustive error handling by implementing a simple helper here. Imagine that you're an engineer in a new project, and your task is to extend the functionality, and while you're persisting the article, you have to also emit a domain event through Kafka. That can lead to a Kafka producer error, which bubbles up into the create article function, which you don't know about because you're new. So don't worry, because the compiler has your back. It will tell you that you forgot to do something. So does this mean that there are no more failures with effect? No, not really. That's the wrong answer. We can have so many other ways to fail. There can be defects that we haven't thought of and are not tracked by the type system, or we just made a simple error in our assumption and we implemented the error handling logic the wrong way. This is where observability comes in. Observability does not only help us with reliability, but also performance and other things. And again, different stages use focus on observability for different reasons. With startups, it's mostly debugging, to be able to quickly fix things while you're implementing new features. With scale-ups, it's performance. Think of finding those slow database queries or N+1 issues. And with the rest of the companies, it's mostly focusing on cost efficiency and security compliance and governance. Think of, audit trails and stuff like that. Today, I want to talk specifically about tracing and what the conventional approach is. We have to wrap our code. We have to have a reference to the tracer, and we have to keep drilling it down to all the underlying functions if we want to have them traced as well. Especially a problematic part is when we want some contextual data to be there, because, for example, the user ID. If we want that, we have to pass it along with the reference of the tracer. in an isolated example like this one, it's not a problem. But think of a large-scale system, a large code base, that suddenly feels like a toil, busy work that we might not want to do. With Effect, it's much easier because there's function composition. So all we need to do is to just call a few more functions and annotate the spans for all of the underlying spans in this trace in one place. So that's ideal. That's exactly what we want. This is how a trace might look like. And the cool thing about Effect is the dev tools, right? Like you can have these traces already in your IDE, and therefore you don't have to spend time deploying to staging just to verify that your telemetry is correct. Another thing I want to talk about is auto-instrumentation. There's these many tracing clients which decided that they want to have a plugin system where you can implement a tracing plugin for a specific third-party library. The problem with this is that it's terrible. Who owns this code? Is it the tracing client owners or is it the library owners? The other problem is duplicated effort. There are too many tracing clients. Datadog has one, Sentry has one, there's one by OpenTelemetry. Effect fundamentally shifts the responsibilities here. It provides a unified platform where the application owners have direct control over the format of the telemetry. So imagine you suddenly get consistent logs, consistent traces, consistent metrics, and you can control the data volume, so therefore you can control your costs. While the library authors, they get to own the telemetry data, so they get to, they can ask you to provide in the GitHub issues some sample traces so that they can help you debug your problems faster. And the tracing clients also win because now the third-party library instrumentation is not their concern anymore. So we arrive at testability. Testability is important because, not only because it's a good tool to prevent regression in functionality, but it also can serve as a good source of documentation. And startups, again, they need to think of retention, mostly because they don't want to lose their first clients. And scale-ups, they want to keep up the momentum, so they need to, again, work with the balance, write application code or write test code. Corporates need profitability. If suddenly their systems start regressing too often, they may lose the clients. And enterprises and so on, it's also about reputational damage and controlling that. So what does it make? So what is easy to test code? How do we get there? It's through dependency injection. Using conventional tools, it's again problematic because of prop drilling. And you have many dependencies. But you could also help yourself a little bit and create these context object-like things. But this doesn't really help you with the testing itself, as we will see soon. So the test code, you still have to provide all the stubbed dependencies, even the ones that the code, even the ones that aren't used by the create article function specifically. For example, the database client. You don't use it in that function, but you still have to provide it as a stub. With Effect, it gets much simpler because you don't have to declare the unused dependencies. You explicitly declare only the dependencies that you need, and then the system will implicitly pass them through, wave them through all the function calls down the line. So no prop drilling. And this gives you more incentives to actually refactor your code. The moment when a large code base hits this weird stage where engineers are like really afraid to make changes, large-scale changes, that's the start, that's the beginning of the end for the project, unless the business injects a huge investment that could be used for something else. Yeah, and the impact on the test code, not huge. You still have to invoke the function with some sort of an input, provide the dependencies, and assert some things. last but not least, I want to talk about adoptability. If your technology is great, it's not a guarantee that it will get adopted. So, companies need to be able to use these new technologies in new systems, but also existing ones. For startups, what is important is the speed. They need frameworks that have batteries included. For scale-ups, it's the scale and developer experience that's important. They need to be able to optimize those slow SQL queries very easily. And for the rest already have vast numbers of existing systems. So the most important factor is interoperability. This is where I want to just quickly show something. It's very easy to go through go between promises and effects. Let's say you have your system, which is built on effect, but you have a third-party library which provides you a function that can calculate the meaning of life, the universe, and everything, but it's a promise. Well, you can use try promise to convert that into an effect, and then it's business as usual. The inverse is also true. You have a legacy system which tries to use this new library providing the meaning of life, and you can wrap it into a promise, and business as usual. Now, this is all nice, but how do we get wide-scale adoption? I'm pretty sure you're all familiar with this bell curve of technology adoption. There are different segments in here. There are innovators, early adopters, and so on. What's important is that they each directly build on top of each other's shoulder. A late majority representative cannot, by definition, adopt your software before somebody from the early adopters does. I think this is where effect is right now. So how do we get to a wide-scale adoption? I think it's important to listen first, talk to the people and see what kind of issues they have, what is the blocker for the adoption. And yes, very oftentimes you will talk to people who are late adopters, they just don't know it yet. We need to move on and focus on people who are more willing. And there's many people who are willing to invest in effect. We just need to inspire them and show them what is it that they can gain. And once we know what the blockers are, we need to build them. This is not always code. Sometimes it can be just addressing a gap in documentation or writing a blog post about your use case, the challenge that you faced, and how you solved it. And sometimes it's coming to conferences like this and talking about these things. I very much look forward to hearing from our speakers today about the challenges that they have been facing and how they solved them. And last but not least, once we have all of these resources, we need to help people and educate them, show them. Sometimes it's very hard to find the answer to your questions. And even more often, it's harder to find the right question to ask. So this is where everybody comes in. And Effect has a great community, which is often a great strength, which people don't necessarily realize immediately. And if we lean onto it and double down on the community, I believe we can unlock Effect's true potential. Become a platform for building high-quality software, fast and cheap. Now, I really just skimmed through all of these things, and there's so much more details that I could tell you. And if you're interested, you can follow my blog where I write about all of these things, and I'm trying to cover each software quality trait every 2 to 3 weeks. So you're very welcome to join, and please leave me some feedback so I can focus on other things, on the things that you missed next time. You can reach out to me on all the social media or here in person. I look forward to having great talks with all of you, and thank you for your attention.